In this clip, we cover 3 miscellaneous topics that might crop up on the A+ exam: error correcting code, or ECC RAM, memory channels, and the various ways that RAM speed can be specified. ECC memory is designed with an extra bit for every byte, called a parity bit, that is used to detect, and sometimes correct, single-bit errors on the RAM module. ECC RAM reduces the risk of data corruption and system crashes, so it's generally a good thing, and we might think it would be used everywhere. But in fact, the application for ECC memory is almost always in the server market, although there are occasional exceptions, such as high-end workstations. As technicians, we need to remember that the ECC capability must be supported by the motherboard. Otherwise, that extra bit just goes to waste, and we may have to turn on the error correction feature in the PC's hardware setup menu. Here's a photo of a DDR3 ECC DIMM from an HP engineering workstation that I used as a server in my office for a few years. Notice that there are 9 chips instead of the usual 8. And here's another DDR3 ECC DIMM, this one from a previous generation Mac Pro. Again, we see 9 chips instead of 8, which lets us know that this is most likely ECC RAM. Now, another concept we need to know about is memory channels. A channel is a wired connection running between the part of the CPU that controls memory and the RAM module itself. The advantage of having more than one channel is that channels can act independently of each other, which means we can move more data around in the same amount of time. Dual-channel memory can make a noticeable difference, and quad-channel memory, while much less common, can improve performance even more. Be sure to remember that the number of channels is not necessarily the same as the number of RAM slots on the motherboard. For example, we can have 2 slots in a single-channel machine, and we can have 4 slots in a dual-channel machine. Now, if we are fortunate enough to be using a dual-channel motherboard, then 2 modules will be faster than 1, even if the total amount of memory is the same. So it's always worth checking whether a machine supports dual-channel RAM before you populate a motherboard with memory, so you can optimize the RAM module layout. Now finally, we need to explain a little bit about how memory speed is measured. The bad news is that there are 3 measurements commonly used by RAM manufacturers. The first is clock speed, which is the rated speed of the memory bus. A bus is just a communications pathway. This value is usually given in megahertz, or millions of cycles per second. Transfer speed, with the unit of mega transfers per second, measures how many actual data transfers occur per second. Now remember that DDR, or dual data rate memory, can make 2 transfers in 1 clock cycle, unlike the older SDRAM. So the transfer speed of a DDR module will be 2 times the clock speed of the bus. This number typically appears after the DDR generation specifier. So for example, DDR4-3200 means that the rated transfer speed is 3200 megatransfers per second. Okay, well, our final measurement is bandwidth, measured in gigabytes or megabytes per second, and which reflects how much data in the form of bytes can move in or out of the memory module per second. This is equal to the transfer speed times 8, because each transfer moves 64 bits, which is the same as 8 bytes. So if all of that seems a bit complicated, just remember these relationships. The transfer speed is twice the clock speed, and the bandwidth is 8 times the transfer speed. Now, to prove that I'm not just making all this up, we can look at a reporting tool running on one of my computers. And we can see that the clock speed is 1600, the transfer speed is 3200, and the maximum bandwidth is 8 times 3200, or 25,600. So why does the industry use 3 different numbers to rate the speed of memory modules? It would certainly be easier if all manufacturers used the same measurement, but this way, exam writers have something extra to quiz us about. Well, I'll end this clip with an exhortation to add memory with the same or better speed rating as what's already on the motherboard. If you mix speed ratings, the end result will not be the average of the 2 ratings, it will be the lower of the 2 speeds.